Bismillahirrahmanirrahim. Assalamu alaikum dear students. As you all know that we have finished our unit number 2 and now we start our numericals, exercise numericals, which are on page number 59. Okay, now come to numerical number 1, that is you can look at page number 59, that a squash ball makes contact with the squash racket and changes velocity from 15 meter per second west to 25 meter per second east in 0.10 second. Determine the vector acceleration of the squash ball. Now dear students, here you can see that the velocities changes from west to east, 15 meter per second to 25 meter per second. So here our initial velocity is 15 meter per second. Okay, and because it is from west to east, now we write the sign of minus with 15 meter per second, because here the velocity changes from west to east in opposite direction of motion. Now in 0.10 second, here the time is also given to you and you will find the acceleration. So our given data will be as initial velocity, that is minus 15 meter per second west, and final velocity, which is 25 meter per second east, and the time is given, that is 0.10 second. Now the required data is acceleration. We find the acceleration A. Now here we can see in our data that VI, VF and T is given to us and we have to find the acceleration. So our formula will be first equation of motion, that is VF equals to VI plus AT. Now here we find the acceleration, so this formula will be A equals to VF minus VI divided by T. Now in the solution we calculate it by putting their values as A equals to 25 meter per second. Here is the minus, and it is VI, that is minus 15 meter per second, and it is the time, that is 0.10 second. Now it is 25 meter per second, and here minus minus plus, so we can write plus 15 meter per second, and it is 0.10 second. Now 25 plus 15 is equals to 40 meter per second and divided by 0.10 second. So we find 40 divided by 0.10, and when we divide these values we find 400 meter per second square towards east. Now our result will be acceleration A equals to 400 meter per second square towards east. Clear to you? Now we start our numerical number 2, that is a golf ball that is initially traveling at 25 meter per second hits a sand traps and slows down with an acceleration of minus 20 meter per second square. Find its displacement after 2.0 second. Now here you can see that initial velocity is 25 meter per second. Okay, acceleration is also given to us, that is minus 20 meter per second square, and the time is also given here 2.0 second. Now we find the displacement. So our given data will be initial velocity VI 25 meter per second and acceleration A equals to minus 20 meter per second square, and the time is given to us, that is 2.0 second. Now we find the displacement, and you know that displacement is represented by S. Now here VI, A and T is given to you and you find the displacement. So we write the formula of second equation of motion, that is S equals to VIT plus half AT square. Now by putting the values we can get S equals to, it is VI, that is 15 meter per second, and it is t time 2.0 second plus half, it is half a minus 20 meter per second square and t square 2.0 second square. Now here it is meter per second, so second is cancelled by second. Okay, and now we can write it as 2 is also cancelled by this, it is 10 meter per second square. So we get 25 meter plus, and it is minus 10 meter per second square into the square of this 2 second is 4 second square. Now multiplying these values, 50 meter plus minus 10 4s 40 meter second, it is cancelled with this. Okay, now 50 meter minus 40 meter, we got 10 meter. Now our displacement is equals to 10 meter. Is it clear to you? Now we come to the third numerical, that is a bullet accelerates the length of the barrel of a gun 0.750 meter long with a magnitude of 5.35 into 10 raised to power 5 meter per second square. With what speed does the bullet exit the barrel? Now in this question you can see that the distance is given to us, that is 0.750 meter, and the acceleration is also given to us 5.35 into 10 raised to power 5 meter per second square. Now when the bullet is accelerated, so it means that the bullet is at rest, so initial velocity will be 0, and we find the with what speed. So here we find the final speed Vf. So our given data will be initial velocity that is given to us in the question, that is 0 meter per second, and the acceleration is also given to us, that is 5.35 into 10 raised to power 5 meter per second square, and the distance s is also given to us, that is 0.750 meter. Now we will find the final velocity, that is our required data Vf, we have to find it. Now for this Vi, A, S and Vf, so here we can write the formula of the third equation of motion, that is 2as equals to Vf square minus Vi square. By putting their values we can get 2 A equals to 5.35 into 10 raised to power 5 meter per second square, S equals to 0.750 meter, Vf square equals to Vf square, and Vi square equals to minus 0 meter per second whole square. Now by multiplying these all values, 2, 5.35, 10 raised to power 5 and 0.750, we get it is 802,500 meter square. Here meter square per second square. Clear? And here the square of the 0 is equals to 0. We got Vf square minus 0. Now it is the value of the Vf square, and we have to find the value of only Vf. So in the next step we are taking the square root on both sides. By taking the square root we get 802,500 meter square per second square. Now the square is cancelled from this end. Clear? Now we got the square of this value is 895 and it is meter per second. So Vf equals to 895 meter per second. It is our final velocity, which is our required data. So I hope that these all numericals is clear to you. So inshallah we will continue the remaining 3 numericals in our next lecture. Okay, till then Allah Hafiz and stay safe, stay home.